I just bought this Nintendo Switch for $37. Customer tried a charging port himself. As we can see, we have a bunch of open line OL, so all of these are supposed to have readings. Screenshot of the repair wiki of what the lines are supposed to read. So yeah, we're gonna see basically how bad or how good of a job he did. I guess he didn't do it that good because we have a bunch of OL, and we're gonna find out, did I waste $37? So we're already missing 2 of these screws, which isn't the end of the world. We're also missing one right here. And we're also missing 2 right here. Yeah, we're also missing 2 screws for the... I mean, they might be in here. He gave me some of these. These are the ports that he has. I don't know which one is which. Okay, so I guess we have some excess screws right here. Hopefully everything I need is in here. Yeah, I can definitely see where some of this stuff is. You have his little bit of solder. I have no idea how good or bad that solder is. If I had to guess, this is probably the port he pulled off. That's odd that he has a whole other set of these 4 long screws. Not sure why. So here's my heating setup. I don't know if you can see, 380, 100% air. I basically use something heavy, and we're gonna pull the port from here. I can already tell you, just from looking at it, it's not great, but yeah, let's get under the microscope. Shout out to the customer, shout out to the guy who sold me this, who said he didn't have the skills to get the port back on, but miraculously, he was able to get the port off without pulling pads, which is a skill in and of itself. Looking over the board, I mean, for the most part, it looks fine. I mean, sort of this part right here, which, what is it? This is for the one of the Joy-Con rails. It seems to be fine. I might have to replace this, but our fuse is good. I don't see any shorts around M92 or P13. I do notice this is a choke right here, and it has continuity across this side. It does not have continuity across this side, so I'm going to pull a choke from an iPad, and then I'm going to replace it here. Now we're going to test for continuity. Which goes something like that, and we're good. So after replacing both M92 and P13, the device still does not want to turn on. But yeah, I found another chip, so I'm going to sort of walk you through that process. And these are general steps that you use with any device, not just a Nintendo. So this is my DC power supply. It is very important that you have it set to the correct number. Can't be too low, can't be too high. So I have it set to 3.6. I connected to the battery terminal. It immediately started to pull current, which I'll show you right now. So I immediately go to my thermal camera right here, and I inject voltage, and I immediately get a particular chip that lights up. So yeah, now we're going to proceed with replacing that chip. So black probe on ground, and then red goes on the line. So any normal device should not pull current before you prompt it to boot by turning the on or off button. So when I dioded this pin and this line wasn't short, it led me to believe that something else was going on. So I started probing around the likely place, which I assumed it was this chip, and it ended up being that chip, but I'll show you that now. Apply a little flux and a little bit of heat, maybe a lot of heat, and the chip comes off. Okay, so that's a step in the right direction. So when I initially dioded the battery connector, I used to get like 200 in something, and this has now jumped to about 490. So based on that, I am inclined to believe that our issue is resolved, but we are still going to inject voltage. So black probe on ground, and we got it. This is pulling 0 amps. Fortunately, I got trolled. So like I said, just because something heats up doesn't mean that it is the culprit. So I need to essentially track down. I have another board at my other shop. So I'm gonna grab that. I'm gonna test basically known good readings for this particular chip, and then reference that, figure out what line is problematic, and we'll go from there. So injecting voltage into the battery connector, all the electricity was running through the battery charging IC, which is that first chip that lit up. Using the same techniques and probing around, I discovered this buck converter IC, and as you can clearly see, it's lighting up. So I'm going to remove this chip and replace, and surprise, surprise, this was the culprit. So we're going to add a little flux and then flatten out these pads before I install my new IC. We're going to give it a little nudge with a little heat, just make sure it was seated properly. Black on ground, red on the line, nothing. So there we go, green across the board. So I'm going to proceed with hooking everything back up. So there we go, we got a charging signal. And this is charging correctly. Our inputs are working. Touch screen is working. And just like that, it turns on, it charges. I've tested all the input devices, so I'm gonna call this repair a success.